Good day, panelists. I'm Carol Comentera. My name is Samantha Erica Di Pinonia.
I am Jai Camilo Chavez. I am Mary Rose Piroso.
And I am Apollo Eric Gonzalez.
And we're here today to present our capstone project titled
ReefCycle, Artificial Coral Reefs from Alcohol Bottle Waste as a Climate-Responsive Marine Solution.
Before we go deeper into our project, let's first take a look at the background and the situation that inspired this study. Studies from the National Oceanic and Atmospheric Administration in 2020 shows that alcohol bottles can be repurposed to create artificial coral reefs. Instead of being discarded, these bottles are transformed into structures that help support marine life in the ocean. Second, research by Bain in 2001 highlights that artificial reefs serves as habitats for various marine organisms. These structures provide safe spaces where fish and other sea creatures can live, grow, and reproduce. And lastly, reports from the United Nations Environment Program in 2021 emphasize that using waste materials helps reduce pollution while protecting marine ecosystem. This approach promotes sustainability and helps lessen the climate impacts on marine environments. Even though reef cycles restore coral reefs and reduce waste, challenges still exist. This leads us to the issues and problems identified. First, climate change and pollution are harming coral reefs. Rising ocean temperature, pollution, and human activities are causing coral bleaching and reef loss. This is harmful because when coral reefs are destroyed, marine animals lose their homes, fish populations decline, and coastal areas become more vulnerable to storms and erosion. Second, there is a growing accumulation of glass bottle waste along coast and in the ocean. Many alcohol bottles are stored improperly and end up in the ocean or on beaches. This is harmful not only to marine animals but also to humans as it pollutes water, harms fish that people rely on for food, and makes coastal areas unsafe. Third, many materials needed for artificial reefs are expensive and hard to find. The less we can restore, the fewer reefs are rebuilt, which makes marine ecosystems weaker and more likely to collapse. And lastly, marine ecosystems face threats due to the lack of simple and eco-friendly solutions. Communities need practical ways to protect and restore marine ecosystems using sustainable and eco-friendly methods and low-cost methods. Simple solutions allow local people to participate, manage, and maintain projects without expensive tools or specialized skills. To respond to these identified issues, we conducted research and brainstorming to develop possible solutions.
So for our research and brainstorming process, we first noticed that many coral reefs are getting damaged, and at the same time, glass waste in the ocean is increasing. These solutions damage marine ecosystem and reduce biodiversity, showing the urgent need for a solution that addresses both environmental harm and marine waste. Next, we look at the artificial reef solutions that already exist and how they are being used. Many current reef designs are costly, hard to maintain, and not fully sustainable, limiting their long-term impact on restoring marine habitats. Because of these problems, we thought of using recycled glass bottles as a possible solution. Using recycled glass offers a practical and eco-friendly approach. It is durable, non-toxic, and widely available, providing a material that can act as an artificial reef while reducing waste. With this idea in mind, we were able to come up with solutions that help reduce glass pollution and support marine life. This leads us to our proposed solution. Our solution is to reuse alcohol bottles and turn them into reef structures. Arranging the bottles into structures forms surfaces and spaces where marine organisms can live and hide, creating a supportive underwater environment. These reef structures will be placed in areas where coral reefs are already damaged. Placing the reefs in degraded areas help attract fish and other marine life, gradually increasing ecosystem diversity. And lastly, this method also helps lessen marine pollution through proper reuse of glass. Reusing glass bottles prevents them from entering the oceans and promotes sustainable recycling, benefiting both environment and local communities. To effectively put these proposed solutions into action, we developed a clear and practical execution plan.
So basically, we'll test to see if using glass bottles or artificial reefs can actually help the environment if it can be comparable to the real reefs. Then we will use alcohol bottles and clean them. will be arranged and will properly bind into cement won't be moved by any disturbances. Then we will work together and will deploy a project in shallow waters where reefs are destroyed, and we will do it carefully. Then we will regularly check the artificial reefs, monitoring the number of fishes visiting and whether the structure stays strong and won't break. Finally, we will see if this project actually helps the environment, and if it's safe to use, if it can be used more widely in areas where reefs are mostly or fully destroyed. Now let's take a closer look at the model itself. As you can see, it's a very simple design, it's not expensive, and it's not hard to make. With the model now ready, you can now focus on the materials and how each one contributes to its functions.
So, we have the materials and function. First, we have alcohol glass bottle. It is used to build artificial reef structures that provide marine life. Second, we have protective tools. So it keeps the people safe when handling bottles and building the reef. Third, we have eco-friendly binding materials. So it holds the bottle together to form a strong artificial reef underwater. Fourth, we have sand and gravel. So it keeps the reef structure stable against waves and currents. Lastly, we have cleaning materials. So it used to clean bottles before placing them in the reef. So with the materials and their roles clearly defined, we can now explain the step-by-step process of how the project is carried out.
Firstly, we will collect used alcohol bottles and clean them thoroughly to make them safe. Then we will use cement and arrange the bottles into a reef-shaped structure. The cement will keep the bottles in place. Then we will test its durability and its balance. We will improve it if it has any flaws. We will deploy it underwater where reefs are destroyed and we will secure it so it won't be moved by anything. Then we will monitor it regularly and check if it helped their marine life. With this process in place, our project offers several benefits for the environment and the community.
So, first is adaptability. The structures are designed to work in different marine environments, especially in damaged reef areas where they can still support marine life. Next is durability. Since glass bottles are strong and resistant to corrosion, the structure can remain stable and effective underwater for a long time. In terms of sustainability, the project recycles discarded alcohol bottles, reducing waste while turning it into useful material for marine ecosystems. For ecological support, the structure provides shelter and surfaces where corals and other marine organisms can grow, helping restore underwater habitats. Finally, regarding climate impact, increasing marine biodiversity helps strengthen ecosystems and make them more resilient to climate change. Looking at how the project performed in terms of adaptability, durability, sustainability, and its impact on the environment, we can now proceed with our conclusion. So, in conclusion, the ReefCycle project shows that discarded alcohol bottles can be reused as artificial coral reefs that support marine life and help restore damaged underwater areas while reducing pollution. This approach is practical, low cost, and sustainable, and it encourages communities to protect marine ecosystems and use resources responsibly.
So, we have here the major references that we use to support our study. First, we have Marine Bioconservation Society 2025. Second, we have Medieros C.M. Da Cruz Tixiera, E. Silva Matios, RFM Adnives GA 2025. Third, we have MDPI 2023. Fourth, we have Philippine News Agency 2020. And lastly, we have Suwardi HDA, Armono DS, and Asuwin GA 2026. And lastly, our audits, a quick look of what the product actually looks like.
And that concludes our presentation. Thank you for your time and attention. We hope our project has given you a better understanding of how simple solutions can help protect our marine environments. And once again, thank you for your time and attention.